Welcome back to another repair video here at Ellensburg Amplifier Repair and Service. Today we have another Crunch PZX2000.1. It's a Class D amplifier by Maxonics. Come in because it quit working. So let's go ahead and peel this cover off here and see what kind of surprises we have today. Sorry, that popping, if you hear it every now and then, it is my chair. Alright, so let's peel this cover off. And see what we got. Oh yes. So, right off the bat, we can just use our visual inspections to see that the power supply transistors have failed in a drastic way, and the gate resistors have also been discolored, if not burnt. So let's go ahead and check for shorts. We know the power supply is bad, but let's check for shorts in the output section here. 7.6. Okay, so let's just go ahead and use our visual aids again. So gate drain source. So between gate and source we have 7.6 ohms. Notice I'm not using diode mode. I've had a video explain why I use resistance more often than not than versus diode mode. Then we have 84 ohms. Gate to source on this one. So this one here is shorted. This one's not. More than likely this one is. So let's go ahead and check the back one here. So gate to source, 78 ohms, and then gate to source, less than 1 ohm. So we know for a fact that this one is shorted. So what you'll find me doing is I'll just take my marker and I'll put an X next to the suspected shorted transistors. And with this kind of short, I'm going to suspect that the IRS 21844 IC has more than likely been damaged. But we'll find out when we pull these transistors out. Let's go ahead and check our rectifiers, which I'm going to be pretty sure that they're going to be okay. Yep. And the rectifiers are looking good. These are pretty durable. It takes a lot to pop a rectifier. More often than not, when you have a failed rectifier, it's going to be from a broken lead on the rectifier itself, from vibration damage. So we already know what the problems are on this board. I'm going to go ahead and check the value of the gate resistors. 29 ohms. So what I'm going to do is I'm going to switch these out for 3205s because this uses the TL, the 494 driver. I'm going to go ahead and switch these out for the 3205s and 47 ohm gate resistors, and then I'll test the drive signal with those 3205s. These are probably going to be the 50 N06s more than likely. Pretty typical for Maxonics boards to use the 50 N06s. Yep, those are the 50 N06 transistors. And these are probably 250Ns. Yeah, and these are 250 ends. So I'm gonna go ahead and switch these out to the 260 ends, and I'm gonna switch these out to the 3205s. So stay tuned. I'll be right back with you. All right, let's go ahead and remove this board here and get to replacing these transistors. So let me get the thermal pads here. Keep them in place. And there's our board. So let me fire up the Hacko here. We will remove all these components in one swipe across the board, and we'll get new components put in. That's how quick and easy these things are. Before I put the output transistors in, I will fire up the board and test the 21844 IC. Again, you will see drive on the low side without transistors in on these boards. So just a quick reassurance that your drive chip is either good or bad before you go and install the transistors. Again, I like to try to verify the drive before installing output transistors. So I'll be right back with you. Let me heat up that Hacko. All right, let's get this Hacko going. As you can see here, I have the parts ready to go. 47 ohm gate resistors, new 3205s, course matched 3205s, ready to go in. So we're just going to start from one side of the board and work our way around. Smoked pretty good. Looks like these transistors failed in a pretty drastic way. Piece by piece, we will remove those. And now we got to pull the gate resistors. Pretty simple, especially with the Hacko. Just like that. And then the output transistors. These might take a little more because these are heavily soldered on the top of the board too. Piece of cake. This Hacko makes short work of even the TO247 size transistors. No need to fight removing transistors if you have a good desoldering tool. And I just wiggle the transistors lightly as I'm heating them up. Not too much because you don't want to tear the vias, but I just wiggle the transistors around just a little bit, just so I see the legs start moving in the via. And that gives me a good idea that I've got the via cleared out. just like that. And that is the removal of all the components. Took just a minute to accomplish that, not too long at all. And then just remove all the dead broken parts here. Get them out of my work area. Get rid of all the output transistors. Oh, and get rid of yesterday's drive IC repair. And now what we'll do is we will fit in the new 3205s and the new gate resistors. Looks like I do need to do a little bit of cleanup on the top side of the board here. So what I'm going to do is just use the Hacko to pull this extra solder off the top. That'll give me a good idea of the condition of the vias, the pads, and then I'll take some isopropyl and clean up the debris of the failed transistors. So again, I couldn't stress more about having a good desoldering tool. A good, well-maintained desoldering tool will make your life a lot easier for amplifier repair. So again, I would look into that. So what we're going to do is just take some isopropyl here real quick and clean up the residue of the failed transistors. A clean board is a happy board. And it takes literally just seconds to clean up the mess of the failure. And then while we're here, we should also check the diodes, just to make sure those are still within tolerance. So we'll go ahead and fire up the meter. And this time I will use diode mode to check the diodes. So let's go ahead and check this out. Good. 6.6. Good. 5.7. Good. 5.8. Good. 6.5. So that's looking great on those diodes. So I have no concern for that. So let me clear my spot again and get the 3205s in place. Going to pre-bend my transistor legs. Just makes them fit easier in the board. And it's really easy. I just take the gap of my tweezers, because it's a flat, it's a, what I should call it, a square edge, and I just bend the transistor legs. Down. You do this enough, you can guess really good at how long you need those transistor legs. And just like that. And then I just place the transistors back where they belong. And you can see that where I've bent the legs brings those transistors right to the spot that they need to be. Just like that. And then I take my gate resistors. These are again 47 ohm for the 3205s. And I will place them in place. I'm so picky that I have to have my resistors even in the right, all in the same orientation, so sorry about that. I gotta have everything perfect in the amplifiers that I work on. So just like that, and then I'll push those resistors down in place. And at the same time, on the back side, I will pull the legs and then bend the legs in place. And that is how I go about replacing those. And then another quick tip on when you're doing these particular Maxonics boards is before you solder your transistors down, make sure that the transistors line up. Let's see if I can get a shot here for you guys. Make sure the transistors line up, because you have screw holes here. So you'll actually want to scoot the transistors over just enough to where they're not in the way of that screw hole, because you don't want that transistor sitting against that screw. So you'll see that one of these transistors is kicked off to the side just a little bit. And then again, I just heat up the Hako. I make sure all these legs are flat on the board. Get my solder. Get the Hako. The Hako is the ultimate multi-purpose tool. And I will just solder one leg in place. And that allows me to be able to remove the board and flip it over and solder the backside of the transistors without the transistors falling out. And the resistors have already been bent in place, so they won't fall out. So let me move the heat sink here, and we'll flip this board over, and we will solder the backside. Again, using my favorite tool. And I know the Hako is a pretty large tool to use for the gate resistors, but that's okay, because it literally, again, only takes a second to solder down. The gates of these. Just like that. And then what I'll do is I'll cut the resistor leads off, turn the Hako back off, let the Hako cool down to preserve the longevity of the heater in the Hako. Cut off the resistor leads to the gates. then I'll use some isopropyl again to clean up the area around the transistor. This will also help expose any flaws in soldering, bridges, you name it. A clean board will show it. Sometimes it does take a little bit of work to clean up all this excess flux, but stay persistent, you will get it. They say time is money. Well, so is a return. A return will cost you more money than the 5 minutes it's going to take to clean up this flux. So, just like that, we're looking good. Of course, right? Is that what I like to say? Of course, we're looking great. Looking super fantastic on this board. This board failed from heat. This came in when we had that really severe heat wave there. What was it, the beginning of July? We were 100 plus degrees here in central Washington, and well, transistors, as they heat up, their rated current decreases. So you can't think that this amplifier will run at the same volume level, at the same percentage that you normally run it in normal conditions. Now, as this board heats up, you will start to lose your current carrying capabilities of the transistors, and that is when you will see failures. I have more boards to repair here at any one given time than I have all year, just due to the heat that we've had and the transistor failures that I'm seeing. So people just need to be aware that we have a saying in the electronics world: heat is a killer. You know, all you game console repair people understand that heat is a killer of any electronic component. Well, that's no exception also to amplifiers. So let me check real quick for any shorts in this. I have one spot here that is kind of questionable. Nope, no short there. No short there, and perfect. So we're looking good. So let me get the power hooked up to this and we will test that IRS 21844. All right, got that scope in the corner there for you. I've got my 12 volts hooked up. Got the foot pedal ready to roll on the 2 amp current limited power supply. Let's see if our drive circuit survived. I'm hoping it did. It's looking like we did. Nice. So let's go ahead and check the drive signal here. Again, these are 3205s with 47 ohm gate resistors. Which isn't looking too bad. So let's go ahead and see. Do we have a gate drive on the low side? Let's find out. Did the IC survive? And yes, the IC survived, at least for the low side. That is great news. This is probably one of the most robust IRS-21844s that I have seen. This is the third time this amplifier's been in. Recognize this? If you go back on my videos, you'll see this board has been in a few times, and I always state this is not a 2000 watt amplifier. This amplifier only has, let me verify this number here with you. This amplifier only produces, and this is RMS voltage here, 42.8 volts on the rails. So, and that is before the output. So you cannot push this amp very hard. This amp, I'll show you when I get all back together. This amp will go into clipping relatively soon. So this is an entry-level amplifier, low power. I'm going to call this low power, even though it says on the top 2000 watts. This is a low power Class D amplifier. And it's been driven into clipping so many times. That's why I say this has got to be one of the most robust IRS-21844s that I have seen. I'm not sure if I replaced this. Let me shine a flashlight on this real quick here. I can't remember if I replaced this 21844 when I originally got it. Yep, this card has been out, so I more than likely replaced that 21844 there. So let me get some IRFs put back in the output here, and we will test the high side, and we will move forward on this. I will be right back with you again. Alright, I'm back. Sorry for that huge delay. I seem to have run out of space on my OneDrive for my videos, so I had to do some shuffling around to make things fit. Alright, so where was I? I removed the 260 ends and I put 250 ends in. This just goes to show you that if you want to change anything, changing one part means you have to change another, and I did not feel like changing the gate resistors and the pull downs on these. The 260s were just heating up too much, so, and these 250 ends, well, with this drive circuit, they're bulletproof. So there's your modulated switching. This is with a 50 hertz input signal. So we're at 80 kilohertz, so looking fantastic there. And then our low side switching. Again, this is modulated. Right there at 78.7 kilohertz. So, and if you notice, the signals on this are absolutely clean. So again, these 250 ends work fantastic with this particular drive setup. And here's the output for you. Let me get everything set back up. So there's your output signal. right there at 51 hertz. So, and they are of course just as cold as can be, and so are the power supply transistors. So everything on this is cool as can be. Of course, your rail resistors there are going to warm up, and so is the inductor. It's not too hot yet. These inductors run fairly warm. But as long as your switching signal is good, these stay pretty calm. Again, the switching signal does look absolutely perfect for me. I have no complaints about this signal here. So yeah, so that's it. That's how quick and easy it is to repair these little Crunch PZX amplifiers. Sure does take a little bit more time if you got to replace the drive IC, but again, this is the third failure of this board, and that IC is still kicking. So thumbs up to that IC. So I will get this all cleaned up, put it back in the heat sink, and we will get this back on the road. Thanks for watching, guys. Hope you enjoy this content. If you do, please like and subscribe, and leave your comments down below. Website is down below also too, if you're interested in any parts for amplifiers, if you're interested in any amplifiers in general, or if you're in need of a repair, go ahead and upper right hand corner of my website, go ahead and click the get the quote link. So I will catch you guys on the next one. Thank you for watching. Oh, update, there was one more thing I wanted to show you guys about this particular amplifier, is where it clips at. This is the most important thing I believe a person needs to know when it comes to these amplifiers, is the clip point. So we watch the screen there. Let me get it set up here for the signal. All right, so if you watch that clip point, I'm sorry, if you watch that screen there, what I'm gonna do is I'm gonna raise the gain, and we're gonna pay attention to the voltage. At what point we start to lose the top. So there's where we start to get into clipping. So we're clipping at 30 volts RMS. And that's when the inductor starts to sing a little bit. And then you get into severe clipping at about 34 volts RMS. So we're going to pull just right outside of clipping. So, and this is with 12 volts input. Let me verify that. 12 volts input. 11.6. If I change my setting, you'll see that we are exactly 12 volts input on my 2 amp supply here. So that 12 volts of input gives us a clip point. Of roughly 30 volts, 31 volts, or you can go into full-on clipping, complete square wave at 37 volts. And that's probably when you're going to start to get in a little bit of trouble there, is when you start getting up into 30 volts. So 26 volts, 27 volts at 12 volts input is where this amplifier clips. And that's when the inductor starts to get hot. That's when these things go south. So please just know that these are not powerhouses. So let's bring it right into clipping. So we'll say 32 volts is when we start to see the clipping of that sine wave there. So now let's take the meter and measure the voltage. So on the meter, you will see 32 volts AC. And that is into clipping. So let me show you both. 32 volts, and there it is, 32 volts there on my scope, and you can see that that sine wave is starting to clip. So when you're setting your amplifier up, and I send you an amplifier that I write 13.8 volts input, and I tell you the voltage at where it clips at a specific input voltage, of course it's based on your head unit and stuff, that is a general area that you don't want to exceed unless you're doing competitions or stuff like that where you just need that brute clipping power. But you need to use your meter to stay out of clipping. And really the only way to do that efficiently is with a scope, knowing your rail voltages, knowing your output voltages, just watching your scope and your meters to help these from coming back. So I just wanted to add that little bit of information there for you guys. When it comes to clipping, I've had several emails asking me what clipping is and how it occurs and what they can do to avoid it. Well, don't exceed your rail voltage. Alrighty guys, thanks for watching. I'll catch you on the next one.